In Java, interfaces are contracts, and these contracts spell out what features a software should have or how an object should behave. An interface is a reference type that can contain only constants, method signatures, default methods, static methods, and nested types. Interfaces like abstract classes cannot be instantiated. They can only be implemented by other classes or extended by other interfaces. In this UML model example, we see a person and a dog class implementing the walkable interface. Now, a person and a dog are similar in some respects. They can both have an age and they can both have a name. And this broken arrow denotes that they are both implementing the walkable interface. So therefore, both a person and a dog can implement this CanWalk method. Now let's look at how we can add this to our person class, and we'll also create a dog class and create and implement the walkable method as well. Now let's jump over to the code. All right, so back in IntelliJ, we are going to implement a walkable interface, and we already have a person class. So we're going to use the same example that we had before of our parent class, and we are going to also create a new animal class. So let us create our animal class. Let's call this animal, or let's call it dog rather. And now let us create our walkable interface. So we'll click File, New, Java class, and click on Interface, and we'll call our interface walkable. And it is usually good convention or good practice to name your interfaces using a verb, right? So walkable, flyable, things like that. So interface is walkable. And inside our interface, we will have one method to be implemented, and this will be the walk method. Now first, let's go to our person class, and we will use the implements keyword to implement our walkable method. And now we get an error because our person class now needs to implement the abstract walk method in our interface. So I'll just have IntelliJ implement this method for me. So I'll click on OK. And now we are overriding the walk method in our interface. And a simple implementation will be a system.out.println, our person is walking. And similarly, in our dog class, we are going to implement our walkable interface. And I'll have IntelliJ implement this method for me. And we're now going to override the walk method. And I am going to print that our dog is walking. All right, so it is good programming practice to use an interface when you're dealing with a method or a feature that different types of classes have in common. So a person can walk and a dog can walk. The best practice is to use an interface and have your classes implement that interface in order for a good object-oriented design. Now let us test this out in our main program. So we can declare a person object, and let's just say person P is equal to a new person. And let's give this person an age. So they're 31 and their name is, let's say Zach, and Zach is male. And now let's declare a dog, and let's call that dog D equals new dog. And our dog does not have a constructor, so we do not have to set any values for our dog. And you can go ahead and implement the UML diagram that we have here and add these data members to your dog class. I'm simply trying to demonstrate the implementation of our walkable interface. So now we can call p.walk, and we can also call d.walk. And when we run our program, we see that both the person and dog are walking. So this is, as I said before, this is a good design to use an interface for features that are similar across different classes. It will make your programs more efficient, and you'll be able to reuse different portions of your code, different interfaces and abstract classes also throughout your program.